if I have a molecule in which electrons are shared, okay, and Lewis dot formulas show that I'm sharing electrons here and here, okay? In this bond just between this hydrogen and this oxygen, there's electrons in here, okay? By definition, if oxygen is pulling on those electrons more strongly than hydrogen is, and it does that, then the electrons are actually spending more time over here toward the oxygen, okay? So if the electrons are more of the time over here closer to oxygen, that makes the oxygen more electronegative because electrons are negative, and the hydrogen more electropositive. Okay, so by definition, a polar bond, one in which you have an uneven sharing of arrangement of electrons, that is, the density of electrons is greater over here than over here. Okay, by definition, that's what a polar bond is. A polar bond is one in which the electrons are shared unevenly. Does that make sense? Yeah, close to either evenly or close to evenly. We have a sort of a range. Remember, we say if the electronegativity difference is less than 0.5 in here, we say that that bond is nonpolar. Now that depends on who's teaching it, because sometimes it's 0.3 or below. But in here, I've been using kind of numbers that are a little easier to follow, so I say 0.5 and below is nonpolar. Okay? That is the electronegativity difference. All right, any questions about that? All right. So then, in number 67 then, the question is, a bond in which one of the atoms attracts the shared pair of electrons more strongly than does the other due to a large difference in electronegativity is a polar bond. Okay?